Core system login in progress.
Alright, let's get going here. Turn to Unity, go to Scenes, the Scenes folder, right click, add a new scene, call it Voxel. Under the Scripts folder, add a new folder, call it Voxel. Name the first, or add another folder. Don't totally need this one, but that's okay. Call it VS Lab 0. Open it. Inside that folder, add a script called VS Lab 0. Save in Unity. Go back to the Scenes folder and open the Voxel scene. Delete the main camera. Go to our Prefabs folder. Drag a character into the scene. Save. Right-click in the hierarchy. Click Create Empty. Reset the transform. And drag our VS Lab 0 onto the transform. Onto the game object. Double-click on the VS Lab 0. And we're ready to go.
Access granted.
Alrighty, let's get back to it. Or get to it. We're going to leave the start and update this time. We need a nugget span or nugget count function. Like most voxel games, that'll be 16. If you want to know where the idea of 16 comes from, 16 squared, or 16 by 16, is 256. And a byte is 0 through 255, so somewhere along in those lines. Our vertex limit will be how many vertices we allow in a mesh. Unity has around, I believe, 64,000. I can't remember the exact number, but has around a 64,000 plus limit on a mesh, on the number of vertices you can have in a mesh. That is basically the size, I believe, of an integer back in Windows 95 or Windows 3.1. And it comes from wave models, object models, wavefront models. All right. We need a simple state machine here. It's going to be it will be an enum for now. Later on, when we create the common will actually also, the common class, the lab common class, we will actually have a common class, but we also have a chunk common or lab common class, and that will be a more complicated version of our state machine, but not much more complicated. Because we are going to use multi-threading later on, I create a ing version of each main or primary state. In threading and multi-threading, sometimes Unity will just not report the error, which is hilarious. So we need a way to get back. We need a way to find the error and to know where something crashed if we did not put a try catch in place. We need a reference to our character camera. And we need some new classes. are some new structs. We are going to put them at the bottom of our class. I like to put classes that I don't want to have a million names for, but I will have structs that I will have in multiple classes, multiple labs. I like to put them embedded in the class, and that way when we go to do lab 1, they can keep the same name. I don't have to constantly append new names onto the struct. Also, it keeps the struct from appearing in the IntelliSense of other labs, since it is embedded in this lab. Material preset is a simple way of working with submeshes. Material preset will point to multiple materials that we'll have. We'll declare in a little while, and this will be the index of each of those materials. So we will normally have 3 or 4 entries in each material presets list. And then our mesh, our model itself, will reference what index in the mat-ins it wants, and then it will use the index from there to set its material in submesh. Now create results will be for the results of creating the mesh to have a quick method of accessing the mesh in its game object, whereas collider will be when we update, when we get into adding and updating nuggets and removing them and changing them, etc. The evaluate results is to hold the results of looping through our mesh, through our nuggets, and deciding what sides from each nugget will appear. Face index group. There will be one face index group for each material. We will look at atlases later on, but for right now, we will be using submeshes, and there will be one face index group for each material. Here's its face indexes, and its index in the array will match the material's index in its array. Right now, we are just going to calculate our tangents. Later on, we will import them from Blender. So here will be our vertices. This will be initialized to our vertex limit that we declared earlier up at the top. This will be, we will use system array resize to actually initialize this for each different chunk And we will always leave these at the size of the vertice limit, and that takes just a little bit of the possible glitching out of our code, or out of our scene, should I say. Total, or the V count, vertice count, at the end of the evaluation of all the nuggets, that will be the size we'll initialize these to. And that will be how many of these will copy over. And this will be more in reference to the face index. Once again, one for each different material. These names are a little bit misleading. This is actually the material count, the total available material count, whereas this is the total material count used. Now these guys are for when we go over, or we're getting close to going over our vertice limit, so we can break processing, go create the mesh, and then come back and process some more. This is where we broke what's the index of the nugget we broke on, +1. These I like to set just for debugging purposes. Column the Y in the row where we broke. And has more is just a convenience field, nothing more. That says that yes, there are more nuggets to process. Here we are resetting. So each new chunk needs to reset information, because they're all going to use one evaluate results in the end when we have multi-chunks. Although we're just working with one chunk right now, let's go ahead and develop this method. So if we broke, meaning that we hit our vertice limit, we do not want to reset the breaks every pass. We only want to reset the breaks when a new chunk calls our method. So we'll pass false if we're calling reset from within a break. go back to the top and declare these.